Hello friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 2492. Minimum score of a path between two cities. In this video, we're going to explain a solution based on union find, also known as disjoint set abstract data type. So here we are given a positive integer n representing n cities numbered from 1 to n. We are also given a 2D array called rows, where rows I equals AI, BI, and distance I, which indicates that there is a bidirectional road between cities AI and BI, with a distance equal to distance I. The cities graph is not necessarily connected. So here, the score of a path between two cities is determined as the minimum distance of a road in this path, right? So we are required to return the minimum possible score of a path between cities 1 and n. So here the nodes are very important. So first, a path is a sequence of roads between two cities. And secondly, it's allowed for a path to contain the same road multiple times. And also, we can visit cities 1 and n multiple times along the road or the path. The test cases are generated such that there is at least one path between a city 1 and a city n. So here are two examples. In the first example, so in the road contains 5. So the it will have the minimum score, that is 5. So we return 5 in example 1. So in example 2, so because 1 and 4 are connected, and also they connected with cities 2 and 3, so the minimal road distance is 2, so the score is 2. So with that said, let's also look at the constraints. Basically, this n is bounded above by 10 to the power 5, and this is a decent large number. So there are no repeated edges, and there is at least one path between 1 and n. So with that said, we're ready to do the analysis. So first, the method here is based on union find. And for this problem, we just need to locate the connected component containing cities 1 and n. So by assumption, so 1 and n are actually lying in the same connected component. So the return is the minimum road distance for rows connecting nodes in this connected components. So well, for finding connected components or component, we typically do union find or traversal, such as breadth first search, depth first search. In this video, we're going to present a solution based on union find. So here, actually, the interested readers could check out the video in my channel in YouTube for traversal-based solution and other problems analysis. So with that said, now we are ready to do the analysis. So here I'm going to implement the union and find method within this function because the number of n is given. So here I'm going to initialize two things. One is root. So here for I in range 1 up to n, right? So we write n plus 1 here. So here we are using dictionary comprehension. So let me copy this part. So I'm going to introduce a rect. So initially the rect will be float infinity. So it's very large. So basically we want this rect or rects to represent the distance within a road and a possible path, I would say, in a road connecting two cities. So with that said, let me first finish the find method, then we explain the union method. So the union method actually encodes the problem logic here. So first, let's define the find method. So given the city, we want to find its root. So this is actually very routine. So here I'm going to write in a iterative format, and I'm going to incorporate path compression. So I'm going to introduce a variable called result or root, and then we're going to do a while loop while result does not equal to root's result. Then we're going to retrieve upwards. So we're going to set result to be roots of result. And however, in order to make this faster, so I'm going to write this, and then we apply roots twice to result. And this actually is playing the role of path compression, right? And then after we exit this while loop, this condition is not held. In other words, we are going to have result and the root's result are the same, so we are going to return result here. So this is the find method. Next, let's look at the union method. So typically in the union method, we accept two arguments, the two nodes or two cities here. But in this one, I also accept another argument, that is the distance. So with that said, let me write this function here. So first, I'm going to find the root I, root j. That is find I, find j, right? And then we're going to check. So typically, if we do not have this one, then if the roots are the same, so we just do nothing and only consider the case that the two roots are different. But here, even they are the same, so we need to do update for distance. So if root I equals root j, what we're going to do, we're going to update the recs. The root I, the rec will be the minimum of recs root I, and then the distance, right? So this is the case. Otherwise, these two are not the same. Then we regard the rec value, smaller rec value is better, right? So we are going to check that. If recs root I is less than or equal to recs root j, it means that this root I corresponding to a better score, right, or better path. Then what we are going to do is set the roots of root j to be root I, and then we update the recs of root I, which is going to be the recs of root I and the smaller one between the distance of this one, right? And otherwise, so we do the same thing, but in the reverse direction. Let me copy this part, these two lines, and then put it here. So we are going to set root I to be root j, and the roots of root I to be root j, and then we are going to update the rec. So for j to be the smaller of the original value and the distance. So this finish is the union operation. So here we can regard this first step as a preparation. Let's call it step 0. So the disjoint set ADT, right? And then next, so we're going to call it step 1. So connect with the problem here. So now what we are going to do first is to do the union operation. So basically, we for item for the information we have. Let's see, for information we have in the rows, right? Then we're going to pass this information to the union, right? So union. So we are going to pass this as a tuple, right? So we're going to do this information. And then this done the graph, basically, or clustering. Then what we are going to do, basically we want to find the roots corresponding to city 1 or city n. Let's see, a root equals to be find for city 1, or you can use find city n, right? Then what we are going to return is just the rec of the root. That's the problem logic. So I guess before we make any extensions or comments, let's first do a check for this case. Yeah, it passes one case. Now let's look at the generic case. Yeah, it passes all the cases very fast. So here you can try n, right? Because the same, because city1 and city_n are in the same cluster or connected component by assumption. Yeah, it passes. So this is the one thing. So, but after we finish this unit operations, if you like, you actually can get all the connected components. So here, let me implement another function, right? Just to get the clusters or get connect components, to print out and visualize that. So here I'm going to use collections default dict. So I'm going to use a set as container. So then for kv in roots items, and then we are going to find the root to be found v, right? Then d root, I'm going to add this current key, right? And then we're going to return d. So now basically before that you can print out, let's see, print get components. So let's test. So this is for, I guess, for example 2, right? So this is the representation of the cluster, the 1. So 1, 2, 3, 4. Then if you try this one, let's see. You can also get 1, 2, 3, 4, and yeah. So we can try one more. Let's see. Let's see. I just write 6, and then I'm going to write 5, 6, and I want to use 100,000. Invalid case. Distance to have value from let's choose a smaller one, 100. At least pass between 1 and n, right? So let me delete this one. Let's see. Okay. Still have no. Let me just write 1, 6. This will be okay. Yeah. So in this case, we are going to have 3 clusters, right? This is the one and another one, right? So with that said, I guess that's about it for this specific problem and this video. So I'm going to comment this out and comment this out. Yeah, and basically this is the solution format for this problem. So yeah, with that said, I guess that's about it for this video. So you are welcome to follow up me in my YouTube channel to do more practices. Thank you.